right. Let's get this current slide set up. Okay, wait a minute. Okay. Everything is okay. Start from the slide. That's why I clicked it. Man, now it goes black again. Now it goes back to regular size. Here we go. We are now recording. We're finally on where we're at. But before we get there, what I've passed out to you now, did everyone who's here get three documents from me this morning? Okay? Now, let's start with the biggest one, the thickest one. In fact, all these are to do with the same thing. I think I mentioned to you before, departmental final exam. Okay? It's different from what I would give as a final exam. I don't really care for multiple choice questions on a math test. I like to see your work. But the departmental final has 30 multiple choice questions. Since I'm not going to give you any multiple choice questions over the term, I've given you some samples to study from. Okay? And answers for those multiple choice questions. Okay? Now let me just check and make sure. Yes. Okay. All right. So your final exam will consider multiple choice questions, 2 points each, 60 points. Okay? And all I grade, it's a Scantron. You either get it right or get it wrong. Okay. Now, I don't care for that kind. I like to give partial credit on the Scantron. The second part of the comprehensive final is short answer. More like what I would do the whole test as if I were giving it. But there's only 8 short answer questions. So I've given you the other handout here has, I think it's 32 or 36, something like that. 32 short answer questions, somewhat similar to what you might see on the final exam. Okay? Now, why give them to you? So that over the course of no better time to start preparing for the final exam than right now. Okay? So as we start doing things in class, if it's something we haven't done, don't worry about it. We're going to get there. Okay? If it's something we have done, you should be able to do it. If you can't get the answer on the multiple choice that's given, good thing to ask me in class or come by office hours. Better in class so that we can work it all together. Okay? These have no answer keys, so if you work through this and you feel very confident about it, fine. But if you don't, if you're uncertain, bring these questions in anytime between now and the end of the term. Okay? So that's what these are for. These are study guides for the final exam. Quite often I have students ask, do you give a study guide? Well, here it is. Okay. Now, you won't see any of these questions, I don't think, on the final, but they'll be similar. JT. Got it. Mark you here once, okay, by mistake. So you're there now. Okay. So, any questions on those? So these are things to start looking at. Got a weekend coming up, nothing to do. Why not work on some math problems? All right. That sounds fun. Okay. Now, another thing. This is pretty important. Don't want to make light of this one. And I announced it last time, but I'm not sure everybody was here who needed to hear it. So I'll say it again. Today, the Vice President sent an email last week saying that today, all non-paid students will be removed from the roll. At the end of business today, I think is when it was. So if you have not completed payment for the course, and of the people in this class, 33 people that had pre-registered, 1 never is shown, but only 5 were listed as not completed. Some of you probably have. Okay, I think on the way out, some of you said on the way. One other person we've never seen. So that only leaves 4. 1 said he was taking care of it. There's 3 more. 2 of those have not been here either day. Okay, that I made the announcement. So if the shoe fits, wear it. If you're not certain, come see me after class, whether you've completed payment or not. Or at least my information is of last Friday, I think it was, when I made the marks in the book. It may have been Thursday, but I believe it was Friday. Okay? Please get that taken care of. Now, if it's in the works, but you still can't do it today, let someone in the business office know that. Where you are in the process, how close it is, when you'll have it in. I think they can put a flag by your name and keep them from removing you from the role. I'm not certain of that, but if they will do it, I know they can do it, but I don't know if they're authorized to do it. But at least give that a shot. So if you haven't completed payment, please let somebody know in the business office what your plans are. What's that? They will? Okay, well then they'll do it here too. Okay. I wasn't sure of that. I knew they had in the past, but I don't know how serious the vice president is. Sometimes the rules change in the middle, and I don't know. So good to hear they will do that. Okay. All right. Any questions before we get going? Okay. Last time we finished all the new techniques that we were going to do in this section, and we were going to start the summary of factoring techniques. Okay, as we have indicated, factoring is an important algebraic skill. Okay, that's how we go about solving problems. Okay, one method anyway. We learned some basic factoring techniques, one at a time. Okay, but you've got to be able to do them however they're thrown at you. Oh, wow. Did you guys mention? Oh, you didn't get one of these. Okay. Huge one. No, I'm just kidding. Okay. It's just a study guide. Okay. Let me. This is summer. All right. Just coming back, I thought I'd give you one. No, I'm just kidding. It's a study guide for the final exam. But let me say this, so everybody will have a chance to have heard it. They will be removing at the end of the business today all students who have not completed payment for the term. Unless you get down there to the cashier's window, the business office somewhere, and let them know what your plans are for completing payment. Then, from what I understand, they will put a flag to keep them from removing you from the roll. Okay? So please get that done today. Either complete payment or let them know what your plans are. All right. Going back here. Oh, the other question I was going to ask. I passed it out last time. I don't know if all of you were here. The quiz for this chapter. I gave it a little early for people who were here. Anyone who did not get a quiz? Okay. Anyone else? Not get the quiz. Okay. All right. I'll let you know when they're due. But since we covered most of the material, I thought you might want to go and get started.
When you passed that up?
I'm sorry?
I said, when you passed that up?
Last time. Yeah. Did you get it?
Yeah, it didn't like it was something back there.
Oh, what I picked up? Yeah. That was my master. Okay. I always recycle paper. So I give you clean paper. Y'all are special. Okay. Huh? You didn't? Okay. Okay, so the pop quiz is due tomorrow, but the quiz you can take a week on. No, I'm just kidding. You can take a week on the quiz. I'll let you know when it's due. Okay. So, like the quiz, that's what brought it to mind, you got to figure out, you must be able to apply whichever is or are appropriate to the situation. Okay? We did it. Okay, let's do the greatest common factor. All right, let's do difference and square. We did them individually. Now you got to be able to pick out what's appropriate. So let's review the techniques. Consider examples to demonstrate the use. General guideline. Always look for the common factor first. Get that out of the way. You'll usually make the problem much simpler to see where to go next. Okay? Remember that common factor could be a binomial factor. Could even be bigger. Most of the time it's not. For instance, what would you do first in that problem? Did you see it? 3x squared, y cubed plus 27xy. What would you do first? Do something first, please, okay? Common factor, and what would it be? 3xy. And what do you have left? Factor out 3xy, there it is. What do you have left? Say again? Okay, I heard an x, I thought I heard a y, I thought I heard a 9. Xy squared plus 9. Got it. Excellent. How about this one? What you look for first? Greatest common factor is the 1. Yeah, you got y plus 2 is a common factor. Factor that out, what you have left? X plus 5. Y'all are good. Maybe a little slow, but good. All right. All right. Now, next, if the polynomial has 2 terms, there's only 2 techniques that we have besides greatest common factor. If you've only got 2 terms, there's only 2 techniques that might work. Difference of 2 perfect squares, or the sum or difference of 2 perfect cubes. Okay? But what do we look for first? Greatest common factor. All right. How about that one? Any greatest common factors? No. So what do we try next? What? Difference of 2 perfect squares. What would it be? Say again? 3a plus 5 times 3a minus 5. All right. How about that one? Any common factors? No. No. So what do we try next? Sum of 2 perfect? Not squares, cubes. And what would be the factor of that? 2x plus 5. 4x. 4x squared. Second. Minus what? A little louder. Minus what?
25.
Okay, not jumping too far ahead. The minus goes with the cross product. What would that be? 10x minus 10x, and then plus 25. Okay, the first and the last are always plus because they're perfect squares. This is the opposite of the cross product here. Okay, good deal. Pretty good deal. Okay. Now, what if the polynomial has 3 terms? Okay. Then the polynomial may factor into the product of 2 binomials. It may not, but it may. We'll try that first. Example 10 that we did earlier presented concrete steps as opposed to wooden steps, okay, for factoring the trinomials. Example 7, factored by trial and error, okay? So there are techniques we'll use. The perfect square trinomial pattern is a special case of that technique. So what would you try on this one? What would you look for first? Common factors, are there any? No. So what do you want to try next? Two basic techniques we've discussed. We mentioned one here. Trial and error. The other one, anyone remember it? AC method. Very good. Which one do you want to do on this one? AC method. Where do we start? Comes from the name. A. What is your A? And C is 5. What do you do with them? Multiply them together. 30 times 5 is 150. Where do you look next? Sign of the last term is positive. That means the two signs have to be the same, but they are negative. Okay? So we're going to have all the possible factors of 150, then both being negative. Okay? They're showing you the answer now, but we're going to work it out because you said you want to do AC method, which is a great idea. So your AC, let me get my pen set up. Your AC is 150. And you want possible factors of 150. There's going to be a few of those, but the product is going to be 150. The sum is going to be negative 31. Okay? Oh, I'm sorry. B is the negative 31. Okay? So let's start with the simplest. We've got a ways to go. The easiest, remember, they both got to be negative. So it's going to be minus, minus. First number, 1 and 150. Those add to be negative 151. Way not negative 31. Okay? Next one. 2 and 75. Those add to be negative 77. Closer, but still no cigars. Okay? Next one. 3 times 50. What do those add to? Negative 53. Still closer, but still no cigars. Okay? Now what would be the next one? Okay, 4 won't go into it, will it? So don't try 4. So next will be negative 5. And what will that be? Negative 30. Is that what someone said? Okay, what does that give us? Negative 35. Oh, so close. But not even a cigarette. Okay. Now, next one. 6. Let's try negative 6. How do we know negative 6 will work? Because 2 and 3 work. So therefore 6 will work too. Okay? And what will it be? A little louder? 35? Oh, 25. What did you say? 25. Okay, that sounds better. Okay? Negative 25. Okay? Let's see, is that right? Yeah. Yeah, that's right. And what do those add to? Ding, 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 ding. We've got a winner. Okay. That is exactly what he wanted to be. Okay? Where do we go from here? We've got the two numbers. What do we do with them? Okay? We write down the 30. You said it right. N squared. Then we split the minus 31n into minus 6n minus 25n. Sure enough, that adds to minus 31n, right? And then we do our plus 5. Now what do we do? Group, exactly. Don't group, okay? So, what do we do with that then? Look for greatest common factors. And the greatest common factor between 30n squared and 6n? 6. 6n. What do you have left? 5n minus 1. Excellent. And then the second group. Okay. Just 5, but not just 5. There's one other little thing. The minus. Pull out the minus with it. Minus 5, and what do you have left? 5n. You pulled out the minus. That left a minus 1. Very good. Now what do we have? What you look for first? Okay, 6n minus 5 times 5n minus 1. That doesn't matter which order you do it. That's perfectly fine. And you can check it and see if it works. 6n times 5n is 30n squared. Fantastic. minus 6n minus 25n is minus 31n plus 5, and you did it. Very good. Okay. Now, in doing that, we saw an illustration of what's going to be next, which what if you have four terms? If you have four terms, the only thing we know is try grouping. Okay? Maybe other things you can do, but right now that's the only one we've had. And we've already done the grouping. Okay, very good. Okay, how about this one? What would you do for a problem like that? So trinomial, only have two methods that we talked about, trial and error and AC, the one we just did. Which you want to try? Try. Trial and error, oh, clever idea. Okay. What would be, and what I like to do with trial and error is unfoil it, right? Because you get two binomials, and we check them by foiling, so let's unfoil. What's the only possible factorization for t to the fourth? T squared times t squared. Well, there's a t squared. The other one's here too, but I don't want to show too much. Okay? Then where do we look? Sign of the last term is? And what does that mean? The two have to be the same. What do they have to be? Plus. So you got a plus and a plus. And what's the only factorization for 2? 1 and 2. Well, there we have it. T plus 2, t squared plus 2 times t squared plus 1. No guarantee that's going to work until you check it. Okay? Let's check it and see what we get. For what? T squared times t squared is? T to the fourth, that works. Outer plus t squared plus 2c squared is 3t squared. We got that one, and plus 2. Yep, that worked. Now, do we stop there? No, we say, can we factor any further? Here's one with a square in it. Can we factor that any further? How about this one? This is the sum of two perfect squares. Can we factor that any further? No, you never can factor the sum of two perfect squares, only the difference. So no, neither one of these will factor any further in the real number system. Okay? So you finished it. Way to go. Any questions on that? Okay? Then, what if the polynomial has 4 terms? What do we do? Try factor by grouping. It may not work, but try it and see if it does. It may be necessary to rearrange the terms before factoring and see if that will help. Okay, how about that? What would you try? You just said it, huh? Group. Second. Group at the first 2 and the second 2. What do you notice about the first 2? Factor out an A, and what do you have left? B plus C. And the second group, factor a plus 4, and what do you have left? B plus C, and guess what you have there? Greatest common factor of? B plus C, and what do you have left? A plus 4, you got it. You can go back and foil that one and see if it works. It does. Now, if none of the mentioned patterns or techniques work, then the polynomial may not be factorable by integers. This is one that will not factor by integers. Okay? You can try, and you'll never get that one to work. You can do a C method, you can do whatever you want, you will not get that to factor. Now, so is that a legitimate answer on a test question or quiz question? Maybe. But it doesn't mean I can't factor it. It just means it's not factorable. So don't say, that's not factorable. That's not factorable. None of these are factorable. I guarantee you most of them are. Okay? Maybe 1 or 2 might not be. Maybe they all are. So don't think that's a legitimate answer on all of them. Okay? Always give it a shot. All right. Any questions? That is the end of the section. I think I've given all these homework exercises before, but in case you weren't here. Oh, by the way, the concept quiz is true-false. Don't expect that on quizzes and stuff. But it's still a good thing to look at to see if you can figure out why those are true or false, okay? And one reason it's a good thing to look at, the answers are given on the very next page. So try the concept quiz. Okay, then problem set 3.6. Any of the odds 1 through 29, quite a few of those. Any of the odds 31 to 55, do some of those. Any of the odds 57 to 61, not that many of those, to do at least one and maybe more. And then any of the odds 63 to 111. There's quite a few of those. Do some of every type, okay? All right, any questions on 3.6? All right. Now, I think I told you earlier that the comprehensive final exams I've seen in the past sometime will have a little more complicated problems than what we talked about. So that's why I like to do a few of the ones from 3.7. Because you may see something like this on the final. You may even have some questions like this on the review sheets I gave you. But in case you do, I want you to be prepared for them. So let's hit these fairly quickly and see what we can do. If I can ever get PowerPoint, there it goes. All right. So let's get the slideshow from current slide. And here we go. Polynomials, equations, and problem solving. This is good stuff, Maynard. Okay. Guess what? Why do we do this? Just to give you something to do to pay for your course? No. It's how to solve problems. So this is really where the rubber meets the road. We want to be able to do it. So we want to solve equations by factoring, and we want to solve word problems that involve factoring. The techniques for factoring trinomials provide us with more power to solve equations. That is the property AB equals 0, if and only if A is equal 0, B is equal 0. That's the technique to use to solve problems. Continues to play an important role as we solve equations that contain factorable trinomials. If you can factor them into a series of factors, but of course, the first thing, set it equal to 0. Then try to factor, and then see what you can do next. So let's do an example. Where do we go on one like this? What would you try first? When you have an equation, what might be a good first step? First step's already done for you. You won't. Okay. Let me time out. Let's start over. If this was a linear equation, what would we do? Solve for x. That's all you do. Solve for x. But this is a quadratic equation. So any equation that has the maximum exponent of 2 or greater, you need to do something first. The first thing you do, make sure you get everything on the one side, 0 on the other side. Then you try what? Factoring. Hey, you got it. I've told y'all what the factoring is, right? The F word in this course, okay? So when I say, what's the F word? It's factoring, okay? Is anyone offended by that? Are you okay with it? All right. All right, so let's see, can we factor this? Now, how do you want to try? You have two techniques. It's a trinomial. What would you try? Second? I can't hear you. Did you say trial and error? No. What did you say?
Yes, trial and error.
Trial and error? Okay. All right. And let's try the first one. What's the only possible factorization of x squared? X and x. Is that what you said, x squared? I couldn't hear you. Okay, sorry. Where do we look next? Sine of the last term. What is it? And what does that tell you? Say again? They've got to be different. One of them's got to be negative. The other's got to be positive. Okay? So what are we looking for? Two numbers multiply to be 12. And because they're different signs, their difference is 11. Two numbers that multiply to be 12, and the difference is 11. 12 and 1. Where do we put what? Negative 12, positive 1. You look at the middle term to say who wins here. The bigger number wins, so therefore it has to be the negative. Okay, can I get your names, please? Jack, say again? I can't hear. Sheffield. Sheffield. Okay. Jay, right? All right. For coming this morning, you get a prize. Okay? It's a podcast. No. Okay. It's a study guide for the final exam. The multiple choice part has answers provided. The short answer doesn't have answers provided. You can go back and listen to the beginning of this class. You'll hear me talk about it. All right. We think we got it factored right? Let's just check it. X times X. X, that's right. X minus 11, minus 12X is? X minus 12X is? Negative 11X minus 12. It works. So where do we go from here? We're done. Oh, good. Shoot. Wow. I thought we were supposed to solve it. Okay. Solving means come up with what X makes it work. We just got the factorization. Now, he's absolutely right if there was no equal sign there. If it said factor that, we're done. It says solve this. We're not done. To solve this, you've got to figure out what the factor is. What the values for X is. That's just the first step. Where do we go from here? Set each of them equal to 0, because the product of two entities to be 0, one or the other's got to be 0. So either X minus 12 is equal to 0, or X plus 1 is equal to 0. That's the only way you can multiply two things together and get 0. One of them's got to be 0. So what do you do with the first one? So X, yeah, you add 12, is that what you said? Okay. I don't hear well. Okay, whoops. Add 12 to both sides, and that give you X equal 12, and over here, subtract 1 from both sides, and that gives you X equal negative 1. Now, frankly, I just checked the factoring earlier just to make sure we factored it right. This is the real check of the problem. If you take this value and put it in here, what's 12 squared? 144. Minus 11 times 12. You want to know that one? 132. So 144 minus 132, what would that be? 144 minus 132. So again, 12 minus 12 is 0. Got the hard one done. Let's do the easy one. Negative 1 squared. 1 minus 1 times negative 1, minus 11 times negative 1. Positive 11. 1 plus 11. 12 minus 12 is 0. We got it. And frankly, folks, anytime your maximum exponent is 2, you cannot have more than 2 solutions. You found 2, that's all, folks. Okay? If that were 3, you might have 3 solutions. Now, you're not guaranteed you're going to have 2 solutions. You may have no solutions. You may have only 1 solution. But you can't have more than 2. And we found 2. Stop there. You've done it. Very good. Let's see how they did it. I bet you it's pretty similar. Okay, they wrote it down again. What a clever move, okay? Then they factored it, just like you factored it. Very good. And then they say each of them equals 0. Perfect. And then they solved and got X equal 12 or X equal minus 1. Then they put it in little solution set. Probably the answers in the back are going to be in solution set, so get used to them. But I don't require that. Give me the answers. I'm happy with it. Okay. Any questions on that? All right. They're skipping 2, 3, 4, 5, 6. Okay. Let's see if we can get those others done. All right. Try to do them quickly. 20x squared plus 7x minus 3 is equal to 0. What would you do first? Second? Factor. Sounds like a good idea. What you really do first, though, make sure that's a 0 at the end. If that's not a 0 at the end, don't waste your time factoring. You've got to make sure. And it is, so factoring is the right answer. Okay, now how do you want to factor it? We have at least 2 techniques that should work. Which one you want to try? Second? AC. You want AC method, okay? So what is your AC? A little louder?
20 times 3.
I can't hear.
20 times 3.
Oh, 20 times negative 3. 20 times negative 3. And what does that equal? Negative 60. Okay, so you got to have 2 numbers that multiply to be negative 60. Whoops, that means one's got to be positive and one's got to be negative. Okay, they need to add to be, what is your B? 7. They need to add to be 7. 2 different sign numbers, one positive, one negative, multiply to be negative 60, add to be positive 7. Who's going to be the big one? Who's going to be the big dog? The positive, because you got to add to be a positive 7. So we're going to make the small number negative and the larger number positive. So give me a small number and a big number that'll be multiplied to be 60. Start with the simplest. Negative 1, positive 60. What do those add to? 59, not 7. Okay? Try another. Negative 2, 30. That certainly multiplies to be negative 60, but it adds to be 28. Still not 7. Next. Negative 3. 20. What does that add to? 17. Closer, but still not 7. Next. Negative 4. 15. What does that add to? 11. Closer, but still not 7. Say again. Negative 5 times 12. What does that add to? 7. Ding, 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 ding. We got a wiener. Okay. So what do we do with that? Say again? Okay, you probably said it right. I just can't hear. So let me get these out of the way since we're not going to do trial and error. Okay? All right. You tell me what to write. 20x squared. I like that. Minus 5x plus 12x. That's what you're separating. You got to put the x's back in there. And then minus 3. That now is equal to 0. Now what do we do with that? Someone said it? Group, okay? So we'll group these 2 and those 2. Okay, what do you notice about the first group? Common factor of 5x. What do you have left? 4x minus 1, and that is a 12x. My parentheses covered my 1 there. Let me clean that up just a little bit. Okay, what do you have here? Plus 3. What do you have left? 4x minus 1. And that's equal to 0. Now what do we have? 5x plus 3 times 4x minus 1 equals 0. Okay, some people may think we're through. We're not. Where do we go from here? Set each of them equal to 0. So either 5x plus 3 is equal to 0, or 4x minus 1 is equal to 0. What do we do with those? Say again? Subtract 3 from both sides. I like that. That gets rid of my 3. 5x equal negative 3, and then what? Divide by 5, and that gives us x equal negative 3/5. I know. Can we have fractions as answers? Sure we can. Perfectly good numbers. We love fractions, don't we? Okay, next. Add 1 to both sides, and what does that give us? 4x equal 1. Now what? Divide by 4, and what does that give us? X equal 1/4. I'm looking forward to checking that one, aren't you? Oh yeah, okay. If we plug in a minus 3/5 here for x, what do you get when you square a minus 3/5? Square minus 3/5. I saw my move, I can't hear it. Square 3/5, negative 3/5. Okay, check again. Okay, square negative. What's negative times negative? Positive. Okay, we got that part down. How about squaring 3? Squaring 5. 25. Okay, it's 9 over 25. So 9 over 25 times 20. Well, let's work this out. That would be 20 times 9 over 25. Okay? We'll hold on for a minute. Let's keep going. Plus 7 times, I'm doing this one. We're plugging in x, negative 3/5. Okay? Minus 3. The question is that equal to 0? If it's not, we're in deep trouble. Okay? Well, let's see if we can do that. I know there's a common factor between 20 and 25. What is it? 5. So 5 will go into 20 how many times? 4 times. 5 will go into 25 how many times? 5 times. So now we have 4 times 9, which is 36/5. 36/5 minus, because plus times minus is minus, right? Got it? 7 times 3 is 21/5. Okay, what is 36/5 minus 21/5? 15/5. And what is 15/5? 3. And 3 minus 3 is 0. So minus 3 equals 0. Perfect. Let's do 1/4. Okay? Maybe a little easier. I don't have much room. So 20. And what's 1/4 squared? Say again? 1/16. Plus 7 times 1/4 minus 3. We wonder if that's equal to 0. Running out of room over there. Well, again, 20 and 16 have a common factor. What is it? 4. 4 will go into 20 how many times? 5. 4 will go into 16? 4 times. So you got 5/4 plus 7/4. What's 5/4 plus 7/4? 12/4, which is 3 minus 3 is indeed 0. Both of those work. Now, you don't have to check if you don't want to, but I'm kind of anal retentive. I like to have right answers, so I always try to, if I have time, check my answers. And we got it right. Good for you. Okay? And they got -3/5 and 1/4. Good for them. You could have checked by looking in the book, but we don't like doing that, do we? Okay. Any questions on that before I delete it? Okay. How about example 3? Solve this one. -2n squared minus 10n, that almost rhymes, okay, plus 12 is equal to 0. Now, is there anything you particularly don't like about that? Or you love that problem? Anything? Second? I really don't like leading, well, never mind. What do you look for first? Let's just forget what I was asking. What do you look for first? Say again? Zero. Oh, 0 at the end? Okay, yeah, that's right. We got it. Now, what do we do next? Factor it. Okay, in factoring it, what do we look for first? Greatest common factor. Do you see any common factors in those terms? A 2. But guess what? Let's not just do a 2. I don't like that minus sign. So let's factor out a -2. Are you okay with that? -2, what do you have left in the first term? N squared. What do you have in the second term? Plus 5n. What do you have in the third term? -6. You got it. And that's equal to 0. Okay, now -2 is a factor, so don't throw it away. Well, actually, you could do something with it, but I won't tell you. Okay, -2 times, now that's a trinomial. So how do you want to approach that? Have 2 techniques at your convenience, and what are they? AC or trial and error. What you want to try on this one? Trial and error. Okay, what would be your first? N times n. Okay. Then where do you look next? Sign of the last term. And what is it? And what does that tell you? These two have to be different. 1, -1, positive. Okay? So what you're looking for now are 2 numbers that multiply to be 6, and because they're different signs, their difference needs to be 5. 2 numbers that multiply to be 6. Say again? 6 and 1, and which win? Who goes where? -1, positive 6. Very good, because the bigger number has to be the positive. Okay? Now what? Set them each equal to 0. So either -2 is equal to 0, or n minus 1 is equal to 0, or n plus 6 is equal to 0. Now, any one of these you want to deal with first? When is -2 equals 0? Never! Not in this universe. -2 is -2, 0 is 0. They can't be the same, okay? They're not the same, so this makes no sense. Now here's the other thing you could have done. Up here, as soon as you factored out the -2, divide it away. Because 0 divided by -2 is still 0. Now you can't do that if your problem says factor that, then you have to leave the -2 in. If it says solve that, yeah, that can't be a solution. Get rid of it. Okay. So, what next? What's that? Add 1 to both sides, and that gives you n is equal to 1, or subtract 6 from both sides, and that gives us n is equal to -6. Very good. Let's check these real quickly and see if they work. What's 1 squared? Say again. 1 minus 2 times 1 is -2. And minus 10 times 1 is? Say again. -10. Negative 2, negative 10 is negative 12 plus 12, 0. Good. Okay, how about 6? A little bigger. Negative 6 squared. 36. Negative 2 times 36 is negative 2 times 36. Say again? Nope. 72, right? All right. Okay, negative 72. Okay, negative 10 times negative 6. What's that? Positive 60. And then plus 12. The question is that equal to 0? We don't know, is it? Well, let's add our positives together. What do you get? 60 plus 12? 72 minus 72? Yes. That's 0. Okay. Any questions? And the solution set, indeed, is negative 6, 1. All right. Any questions on that one? Okay. Let's erase all those and see if we can squeeze this one in. Okay. 16x squared minus 56x plus 49 is equal to 0. Whoa! That is a 16. My pen kind of slipped on me there. Okay. What are you going to do first? It's always a good idea. Second? Common factors, are there any? Okay, 16 has factors of 2 times 2 times 2 times 2. Okay? 56 has a 2 in it. 2 times 2 times 2 times 7. So you got a bunch of 2s. Well, what's 49? 7 times 7. No 2s. Nothing in common. So can't do a common factor. Shucks. Those are big numbers. I didn't like them. So what do we try next? Say again? Trial and error. Okay. I think we can handle that. Because it's equal to 0, but we check that first, right? Now, what you want to try first? Say again? Possible factorization for 16x squared. 4x times 4x. And then we look where next? Sign of the last term is positive, meaning these two signs have to be the same. And what do they have to be? Negative, negative. Got it. Okay? What you want to try for 49? Possible factorization is 49. I saw the lips move. What do you get? Come on. 7 times 7. Woo! Does that look like that could be a perfect square trinomial? It sure does. We could have saved ourselves a little grief if we had noticed that. But let's see if it works. 4x times 4x, sure enough, is 16x squared minus 28x, and another 28x is 56x plus 49. Yes, it works. So what's our solution? Where do we go from here? Set them each equals 0. 4x minus 7 equals 0, or 4x minus 7 equals 0. Hey, sort of redundant here. Say again? No, you don't. Okay. You add 7 to both sides, and that gives you 4x is equal to 7. Divide by 4, and you got x equal 7/4. If you do the other side, you get the same thing. Now remember I said when your maximum exponent is 2, you can have a maximum of 2 solutions, but you may only have one, like in this case, You may have 0. We haven't run into that yet. But this one only has 1 because it's a perfect square trinomial. Okay? It's kind of like, I don't know if you remember the old Bob Newhart show, one of them anyway. He had so many of them. But anyway, he had this guy that did work for him. And he was a guy with his 2 brothers, he said. He had a name, here's my brother something, and my other brother had the same name. So it's sort of like here. It has 2 factors, it's that factor and that factor. They're the same ones, okay? So you only have 1 solution. All right. Unfortunately, oh no, we've run out of time. So we'll start next time with, at the top of page 168, with example 5. I had planned to do faster than this, but it just didn't work, did it? Okay, we'll start with example 5. Homework exercises here. We're almost through, folks. Homework exercises here. Any of the odds 1 through 53. Okay, we may not have done all those, so do those that you can, and we'll do the rest of them next time. That's on page 170 and the very beginning of 171. Okay, please, folks, if you haven't paid or you're not sure if you're not paid, see me before you leave, and I'll let you know if you're indicated to be paid. Okay? Good deal. Oh, good deal. Thank you. You certainly may. Good deal. Thank you. Anyone who's finished the quiz, I'll take them anytime.
I'm going to make a copy of this.
Okay.
I can sit down in your drawer.
What's that?
I can put it in your drawer.
In my,
In the
under my door? Yeah, sure.
Okay.
I'm fine sitting here. Good deal. Thank you. Good deal. Excellent. Excellent. Way to go. Okay, Ethan, did you know you were listed in my page?
Yes, sir. I already did.
You're there. Okay, fantastic. Just want to make sure you.
Yes, sir. I did.
All right. Thank you. What's that?
Show my work.
Okay. Oh, I see. Right. Thank you so much.